Hello all. We are dealing with the chapter periodic classification and we are seeing the previous year questions chapter wise of the chapter periodic classification. In part 1 of the video we covered from PYQs 2008 to 2014. We saw all the questions and we have solved it. 2015 and 16 there were no questions from this chapter. Now let's see from 2017 to 2025 what are the questions that I have asked. One thing that I have noticed over the period of time, the number of questions from this chapter has been reduced to one or two. Previously, in 2008 to 2014, the questions were 3 to 4 questions were asked from this chapter. So having said that, let's start of 2014 question. First one question is related to electronegativity. Let's see. The electronegativity of carbon, nitrogen, silicon, and phosphorus are in the order. So let's find electronegativity. The trend of electronegativity along the period and down the group. Along the period, electronegativity increases, and down the group electronegativity decreases. There is no such exception. It is very simple and the easiest trend among all the 4 trends. So along now carbon, we have carbon in the second period, carbon, nitrogen, and below carbon we have silicon, and below nitrogen we have phosphorus. First we need to see period, then followed by group. So the order is the highest along the period electronegativity increases. So nitrogen will have highest electronegative among this 4 element. Next comes carbon. Then it is again if you compare silicon and phosphorus, phosphorus is highest electronegativity. If you compare with silicon, phosphorus, then silicon. So the option is we have silicon, phosphorus, carbon, nitrogen. 6C is the answer. Option C. This is 2017 paper. Moving on with 2018 paper. Which of the following is the correct order of the radius? So here there are 4 options. These all are based on isoelectron. These 3 are based on isoelectronic species. This is an option elimination method. Let's see the first one. Is it right or wrong? Hydrogen is negative greater than neutral atom than the cation. Yes, this is the right option. We know we have studied an ionic radius. The trick is anion for the same atom, anion part is greater than the neutral atom than the cation. Why? Because of Z effect. Here one more electron is added, so there is repulsion between the 2 electrons, and that's the reason radius increases. Neutral atom there is no change. In cation, as 1 electron is removed, but Z effective is same, so there will be more power for the nucleus to attract the remaining electron. So the power will be more, and that's the reason size decreases. So this is the order. You can write down this trick. The first option is right. Let's move on to 2019 paper. The element in which electrons are progressively filled in 4f orbital. Okay. For f orbital, we see electrons filling in 4f and 5f orbital. 4f usually for we see in lanthanoids. So F series, F orbital, we have lanthanoid series and we have actinoid series. So 4f filling will be seen in lanthanoid series and 5f in actinoid. Hope you know where is lanthanoid and actinoid. They are from group 3. They are kept separately, and this is in 4th period. These are in these are not in 4th period, 6th period, and these are in 7th period. So 4f filling is observed in lanthanoid series and 5f is actinoid. The correct answer is lanthanoids. Option B. Let's see 2020. So these are indirectly the paragraph are very big, but the question is very simple, direct questions. The last element of the P block, okay, last element of the P block, we know we have S here, D, we have P block or P block. There are six groups altogether. The last element of the P block in 6th period is represented by the outermost electronic configuration. Okay, what is the electronic configuration of last P block element? So last element will be somewhere here, but they are asking of 6th period. 6th period means n is equal to 6. So let's see which has n is equal to 6, means the last electron will be filling to the 6th, n is equal to 6th value. So here we need n is equal to, the highest value of n must be 6. Here highest value of n is 6. That's true. Here it is 7. That this can't be a possibility. Here the highest n value must be 6, but here we have 7. This also not possible. Here we have 6. So we have two options, that is A and D. And they have mentioned it as last element. It must be, if it's mentioned as last element, so last element, if you see, that will be somewhere from group 18th period. That group 18, they have fully filled electronic configuration. So among 6p4 and 6p6, fully filled is 6p6. So option is A. Hope that is clear. Next, let's move on to 2021 paper. The third ionization enthalpy. Okay, third ionization they have asked. What is ionization enthalpy? Energy required to remove an electron from outermost shell. We have alkali metal. Let's write all the electronic configuration. Alkali metal, they have NS1 configuration. Alkali earth metal, they have NS2 configuration. Chalco, before that, nitrogens, P is silent. These are nothing but group nitrogen family. They have NP3 configuration. And next is chalcogens. We have chalcogen means oxygen family. They have NP4 configuration. N can be based on the period. For oxygen it is 2p4. Next, if it is for sulfur, it will be 3p4, depending on the n value, period value. Now if you see here, let's see how in nitrogen chalcogen happens. Third ionization enthalpy they have asked. So first ionization enthalpy will be NP3, second will be NP2, and third will be NP1. So to remove this electron, as such, a normal ionization enthalpy is sufficient. Too much is not required because it is not fully filled nor it is half filled. So this is eliminated. Next we have is NP3. So first NP3. So first ionization enthalpy, the this is first, this is second. Okay, third. First ionization will be NP2. Next is to remove electron from NP3 first. Next you will remove second electron from NP2. There will be NP1. So we will be removing electron from NP1 here. Here also, sorry, I am wrong. Here you will remove, first you will remove electron from this, then from this, then from, so third ionization enthalpy comes here. So to remove one electron from NP2, as such similar only more number of ionization enthalpy is required, but not highest, because it's just NP2. Here also we have NP1, as it is not fully filled, it is not half filled. Difference of these, if you see the difference, that much of amount of ionization enthalpy is added. This is for nitrogens. If you see alkali metal, here also we have NS2. Here also we will be having NS2, NS1 configuration. I'll take example of beryllium. Beryllium we have 1s2, 2s2, right? The beryllium configuration. If I give first ionization enthalpy to remove this electron, so it will be 1s2, 2s1. Second ionization to remove this electron, again it will be 1s2, 2s0. Third will be removed from 1s2 configuration. This 1s2 configuration, it is very difficult. Why? First is because of smaller size. First is because fully filled inert pair configuration, fully filled inert configuration they have, that is of the helium configuration. Second is due to the smaller size, it is very difficult to remove and they require more ionization enthalpy than the NP1 or NP2. For alkali, again, let's take example of lithium. We have 2 to S1. So first ionization enthalpy to remove this electron will be 1s2. Second is very more because it is 1s2 configuration. Second ionization, it will be 1s1. So third, to remove it is half filled. It requires more energy, but if you compare 1s2, this requires higher energy. So the option is alkaline earth metal. Hope it is clear. Due to the fully filled helium electronic configuration or fully filled noble gas configuration, that's the reason the third ionization enthalpy of alkaline earth metal is more. Now let's see what 2022 paper, which noble gas has the least tendency to form compound. Least means they do not take part in reaction or to form a compound. We all know noble gas, they are inert, they do not take part. But out of noble gas, which is the least that doesn't even take part, that is answer is helium. Why? Because one thing, due to the small size, it is very difficult to remove and electron. It is very difficult to disturb them as they are stable electronic configuration. They are already stable, so they do not take part in configuration. One more thing is small set. One more thing is they have their ionization enthalpy require more ionization enthalpy in helium has the highest ionization enthalpy. They have highest ionization enthalpy. What is an ionization enthalpy? Energy, or we can say electron gain. Sorry, not electron gain. Highest ionization enthalpy means electron, to remove an outermost electron, they require more energy. This helium, to remove these electrons, outermost electron, they could require more energy in helium. Why? Due to their smaller size and stable configuration. So the answer is helium. Answer is helium. Next question. Property of halogen which is not correctly matched. Okay. Property of halogen. First, let's see this part. Density, that is true. Density is equal to mass by volume. As mass increases, density increases. Iodine has greater than bromine, chlorine. This is right. Next, ionization enthalpy. Ionization enthalpy is energy required to remove an outermost electron. Down the group, ionization enthalpy decreases. This is also right order. Next, we have electronegativity. Down the electronegativity decreases. This is also right order. One thing that is wrong is this. Why? Electron gain enthalpy. Electron gain enthalpy, or other form is electron affinity. If you see electron gain enthalpy or electron affinity order, it is chlorine has highest electron gain enthalpy, then fluorine, then bromine, then iodine. Why? Because fluorine has smaller size. Due to smaller size, so if you add one electron to this fluorine atom, already that is the electrons that is present in the fluorine, they have higher electron repulsion with the upcoming electron. So what happens? Why everywhere electron repulsion happens, but here in fluorine they have higher electron repulsion. Why? Due to their smaller size. So when you compare chlorine and fluorine, chlorine has higher electron gain enthalpy than that of fluorine. So the correct order is chlorine, fluorine, bromine, iodine. But so this is the correct order. The answer is A, the property of halogen which is not correctly matched. Next one, elements X, Y, Z have atomic number 19, 37, 54. So always when such question is given, first write down the noble gas configuration: helium, neon, argon, krypton, xenon, radon. Write the atomic number 2, 10, 18, 36, 54. They have told XYZ, they have atomic number 19, 30. So after 18 we have 19. We have here 19. That is nothing but potassium. After 36 is 37. So we have hydrogen, lithium, sodium, potassium, rubidium we have. And after 54 we have 55. Here it is cesium. And everywhere the question is ionization, ionization. So ionization energy or ionization potential down the group, ionization energy decreases. So these are the things we know. Now let's see question and let's see which statement is true. Y would have higher ionization. So this is X, this is Y, this is Z. So let's see the options. Y would have highest ionization of Y. No, that is wrong. Among X, Y, Z, X has the highest ionization energy. Y ionization energy decreases down the group. So option A is ruled out. Their ionization potential would increase with increase in atomic number. No. Atomic number 19, 37, 55, it is increasing, but the ionization energy is decreasing. Second option also ruled out. Y would have ionization and potential between those of X and Z. Okay, this is Z. Y would have ionization potential between X and Z. Yes, that is right. This is correct. Next, Z would have highest ionization. The Z, no, this help having least. So right option is C. Next, 2023. The correct first ionization enthalpy, often given a limit. Ionization enthalpy is energy required to remove the valence shell electron. The ionization enthalpy will be highest or more if the configuration is fully filled or half filled. This you must know. So we have in the option, I can see beryllium, lithium, boron, carbon. Okay, beryllium, lithium, boron and carbon. Okay, here write the configuration. We have 2s1, 2s2, 2p1, 2p2. Ionization enthalpy along the period, ionization enthalpy increases down the group, ionization enthalpy decreases. We know that. So we think the right option is lithium, highest is carbon, next boron, next beryllium. But this option is wrong. Why? If you compare beryllium and boron, beryllium has higher fully filled stable configuration. So we require more energy to remove this electron. So right option is lithium. We have carbon highest, then comes beryllium, then boron, then lithium. Why? They have stable electronic configuration. So option is lithium, boron. Okay, option is D. Next, a pair of amphoteric oxide. Okay, this is concept based. You need to memorize this. In general, in periodic table toward left side we have basic oxide, that is S block element, and towards right side we have acidic oxide, those are of P block element. In that also few are amphoteric. What is the meaning of amphoteric? That reacts both with acid and base. Basic. Okay, this is about amphoteric. Now let's see beryllium. The correct option, beryllium oxide, is amphoteric. Boron is present in P block, right side, it is acidic. BO3 is acidic. BO, so this option is ruled out. BeO, beryllium oxide, this is amphoteric. Mg is S block, this is basic. So option 2 is B is also ruled out. Beryllium oxide, zinc oxide, both are amphoteric. So this is the right option. Next is AlO3. This is amphoteric, but lithium is in S block. This is basic. So D option is also ruled out. So correct option is C. 2024, a metalloid is nothing but they have nature or character as that between metal and non-metal. So in our periodic table there are few metalloids that are present. Those are boron, silicon, germanium, arsenic, tin, not tin, antimony, tellurium and polonium. So right option, this is bismuth, that is not that is a non-metal. Phosphorus not present, that answer is antimony, B. These are all concept based. This is concept based, not concept, memory based. This is also memory based. 2025 question, and I think this is the last question, the previous last year paper. It is from, no one expected the question would be asked from this triad option. So if you recall, Dobereiner triad, what is Dobereiner triad? He made a group of 3 elements and named them triad. How he made group of 3 elements? Those that had similar property. And after Mendeleev, after modern periodic table, we know that similar property are present in group, down the group or in a group, and not in period. You can, on how to find out, there was Dobereiner one statement, that is, if there is A, B, C elements, atomic weight of B is equal to average sum of atomic weight of A plus atomic weight of B, atomic weight of middle element, that is B, is equal to average of atomic weight of first and third element. So by this you can find out, like you can, beryllium is 137, strontium is 88, calcium is 44. In that way you can find out, and you can see whether this is triad or not. But instead of that is a longer process. Instead of that, you can see elimination method of that of option. If you see boron, strontium, calcium, all these are in group, so they have similar properties, so they are triad. Okay, that does not a triad, so this is a triad. Chlorine, bromine, iodine, they fall under same group, so they have similar properties, also triad. Lithium, sodium, potassium, first group, they are also triad, similar in the same group. Chlorine, no, chlorine is in 17th group, potassium is in first group, calcium is in second group. All are in different group, though they are in same period, they are in different, not same period, they are in not same period, but they are in different period. So in different period they don't have similar property. Correct option is C. This way you can follow. So hope this is clear. We are done with the PYQs of chapter periodic table right from 2008 to 2025. Hope you liked both the videos. If you have any queries, comment down below. Thank you.